Greetings everyone. Today we're going to explore solving compound inequalities. So far this year we have been working on single inequalities where we have a graph going in a left or right direction. But what we're adding on today is we're going to have two notations on our graph. And those notations will either be going apart like this or coming and meeting in the middle like this. Let's explore those two options. First, make sure you have your notes open to where you need to be, and always remember to pause the video if you need. Let's start with the compound and inequalities. A compound inequality that uses the word and is known as a conjunction. Conjunction meaning coming together, connected. And so every graph that says and will come together. But there's also another way to write this. Anytime you have an inequality with the variable in the middle. Yeah, that looks weird, right? But we're going to work on that. We're going to talk about when it's in the middle, we graph in the middle. All right, so let's start off with what does that kind of graph look like? Let's break this sentence apart into two pieces. The two pieces are separated by the word and. Our first piece says we want to graph all real numbers that are greater than -3. -3, greater than means open circle, greater than means to the right. If you do not understand that part, make sure you go and see my playlist and my previous videos. The second part says less than 2. So let me create a good number line. -3, -2, -1, 0, 1, 2. Right? Make sure it's accurately numbered. Less than 2. That's an open circle going left. Do you see how they meet in the middle? They meet in the middle. And a way to write that could be x in the middle, smallest number, biggest number. We point to the smaller number. We open the bigger number. Let's try this next one. Let's look for our keyword and. Here's and. Our first statement says all real numbers that are greater than or equal to -1. Greater than or equal to means a solid dot, and we are going to the right, greater than. 4. The second statement says 4. Let's count 4. -1, 0, 1, 2, 3, 4. Right? I am going to check that your spacing is correct. Your number line is correct. Less than 4 means open to the left. And technically, you don't need arrows. Right? You don't need arrows. You could do two dots, the solid dot and the open dot, and you can connect in the middle, or you can shade in the middle. So if I'm in the middle, my bigger number goes on the right, my smaller number goes on the left. We're or equals to at -1. That's how we could write that graph as an inequality. Look at how they compare. Solid, open, left, right. So what if we're asked to solve an inequality where there's information in the middle? This is new, okay? This looks different than what you're used to. This is special. So I have been teaching you to draw lines down equal signs, lines down inequality signs, but I have two of them. So guess what? I draw two lines. Now you care about what's in the middle. If I look at my expression, if I look at my variable has a -5. Well, what's the opposite? How do I get rid of that? How do I get the letter by itself? I need to undo the -5. Now here's where you got to slow down. What you do to one side, you do to all sides. What you undo to one piece, you undo to all. We expect that to cancel, right? We're opposite operations. They cancel each other out. So the x falls down, my symbols fall down. Take care of your calculations. And that's it. My variable's by itself. Now my smallest number is -3. My biggest number is +3. they both get open circles, right? You can do that easily. Now, what's new and what you have to think about, if x is in the middle, we shade in the middle. Okay, make that little note somewhere. If x is in the middle, we shade in the middle. I don't care if you go up and over to connect your dots or zigzag or shading, that's up to you, of course. Because if I read this another way, you don't have to write this part down, but if I think about this, this is saying x is less than 3, left of 3, and x is greater than negative 3, right? Because I would flip-flop that. So if I take a look at this, it's just another way of writing those two statements separately. Okay? And so this part in the red is kind of the cheat. It's not really mathematical, it's more of a cheat that if your variable's in the middle, we are shading in the middle. All right, let's try one with another step. Great one to study. So if you're studying for a learning check, this is the best. In the middle, if I concentrate on my expression, am I going to kick the 2 out first or the 4 out first? Yep, that's right. If you're struggling with these operations, go back to your equations work. We're going to undo the plus 4 from all 3 sides. Opposites cancel. Opposites cancel. Take care of your calculations. I care about the variable. It says 2 times x, so we're going to undo that and divide every piece by 2. Opposites cancel. X is now isolated. Take care of your calculations. Throw those numbers on a number line. I don't need every number, but I need it evenly spaced correctly. Both values get a solid dot. And what we're saying is what numbers are greater than or equal to 3 and less than 10? All of these numbers, right? 6 is in between them. 6.5 is in between them. 9.5 is in between them. All the numbers in between are true. All right, let's take a look at this example. And the first thing I'm going to recommend is please star this example. You're going to see this again. All right. Now, my expression, is in the middle. I care about where my letter is. We have 2 inequalities, so we're drawing 2 lines. Now, the first thing I notice is that that divide by 2 is in the way. So I'm going to times by 2. Those are opposites, right? We got to get rid of the denominator. So the left side is all right. The right side is all right. The symbols fall down. Be careful in the middle, though. A divide 2 and a times 2 are opposites. You're not changing any numbers in the middle. The 6 stays, the negative x stays. You cancel the 2's. That's why I had you star this. That gets forgotten. Divide 2 and times 2 are opposites, cross them off. Okay? The only thing that we didn't use was the 6 minus x. All right, our next step is undo any addition or subtraction. This is a positive 6, so we're going to minus 6. And you might be thinking, well, it says minus. No, that minus belongs to the x. That minus is a negative 1 out front. So then our last step says undo any multiplication or division. Instead of times negative 1, we're going to divide by negative 1. Divide, divide, divide. But let's stop for a moment. We just divided by a negative, so what do? Golden rule says flip your inequalities. If you're struggling with that, please see the other inequality videos. A negative 8 divided by a negative 1 is a positive 8. 0 divided by anything is 0. Now this looks kind of weird, right? Because 0, 1, 2, 3, 4, 5, 6, 7, 8 comes before 8 on a number line. And that's not in the same order. And so we've talked about this in class. You can flip-flop your entire inequality. If you flip-flop it, you flip-flop all of it, right? You see how I completely reversed. And so x is in the middle. We have solid dots, and we're going to shade in between them. That means all of the numbers in between would work in that inequality, would make it true. Now let's also address this scenario. In this scenario, we are given the word and. So my brain says right away, oh, so in the end, I'm going to have two graphs that meet in the middle. Every and inequality, I like chocolate and vanilla. I exist in the middle, okay? And so in this scenario, we get to treat each inequality like its own, right? These are actually kind of easier because we don't have to worry about special rules. We're just solving like we do. I have a 7, let's go solve the other one, right? I'm zooming through this because this is two-step equation inequality work. And so I'm not going to spend a lot of time on this. If you're struggling here, make sure to see my other videos. Now let's stop for a quick moment. We just divided by a negative. The golden rule says we flip the inequality symbol. So now let's plot our numbers. We have 7, 8, 9. 9 is open, 7 solid, and you guys, I don't even have to think about it. If it says and, it meets in the middle, right? Or if I think about it, greater than 7 means to the right, less than 9 means to the left. That's the mathematical reasoning. All right, let's switch gears to what I believe is the easier option. I think ors are easier. Ors are more basic. You will always be given the word or. And here's the thing, if I am talking about a Venn diagram, right? If I talk about chocolate or vanilla ice cream, it's one or the other. I don't exist in the middle, right? I'm over here to the left or I'm over here to the right. And so if you use that sort of analogy, that'll help you remember we're going left or right. This is known as a disjunction. Disjunction. And so my graph in my mind, I'm already thinking that I need to go apart. So let's take a look at this keyword or. It's in the middle of my statements. All right. My first statement says all real numbers that are less than 0. All right, let's go to 0. Open, less than. Less than means left. All right, let's look at our second statement. Greater than or equal to 5. Greater than or equal to is solid. Greater than. Look at that, we're going apart. If it has that keyword or, we will always go left or right. Let's try this one. Look for that keyword or. Sometimes you're going to see the word or a few times, but we care about where is it in between the statements. Let's start off with our first one. We want all real numbers that are less than or equal to -2. That's solid and left. Second statement says greater than or equal to 2. Solid, right. Or means you go left or right. Now algebraically, see how easy this looks, right? We have the word or in the middle, so my brain already says left or right, and we have two completely separate inequalities. We treat them separate. So let's take care of our first inequality, and I'm going to zoom through this because solving 2 steps should be easy and quick. We've got a 3. I'm also going to solve this inequality. It is its own entity. Special rule says that when we multiply or divide by a negative, we need to flip our sign. So we are going to be flipped this way now. Okay, make sure that stands out somehow to you, all right? So I have 3 and I have 6. 3, 4, 5, 6. We are open on both. We're going to be less than 3 or greater than 6. It works out. It makes sense. They go apart. Okay, let's try out this one. Or we want to solve them separately. So let's start off with the first one. Let's kick this over first. Again, I'm zooming through if you need to slow down, if you need to pause, or maybe pause and try it on your own. See how you do. There's our first one. Let's solve our second one. All right, let's divide, and we've got this. All right, there's our two numbers. We've got -1, 0, 1, 2, 3, 4. Please make sure your number line is always correct. -1 gets a solid dot. 4 gets an open dot. Greater than 4 or less than or equal to -1. We're going apart, left or right. My challenge to you on this one would be try this one just for the solving part of it, right? That'd be a good review as far as solving. If you need to pause, do the work, and then check your answer, try it out. I'm going to start with this one. Now be careful. We actually have to kick the 5 over first. Why? Because we can, right? Nothing is in the way of the 5. Nothing's in the way, so we can deal with that. But now the 2's in the way, right? Divide 2 and times 2 are opposites. They go away. Put a little star by that one, okay? That is going to show up later as well. Let's -2 and let's divide by 7. Oh, I'm running out of room there, so I'm going to write right below. We've got x is greater than 2. My apologies for the crammed writing there. Let's take a look at the next one. Divide 4, so we're going to times 4. Why? Because that fraction bar is in the way. I can't move anything from the numerator until the denominator is gone. This is a +4, so we're going to -4. We're going to divide by -2. Oh, hold up. We just divided by -2. Right? If we divide by -2, we got to flip our signs. We've got this and a -2. All right, there's my two statements. We have -2 on the number line and +2 on the number line. -2 gets an open circle. +2 also gets an open circle. We want to be greater than 2, and we want to be, or we want to be less than -2. It's an or, so we go left or right. All right, please consider pausing and just trying out this problem. I'm going to zoom through this with all one color. This one is not special. We can kick the 3 over first. We've solved ones like this before. Times both sides by 2, and we've got 4. Let's solve this one. Again, I'm zooming. Why? Because we've done this before. If you need to slow down and pause, please do so. All right, -2 is open, +4 is greater than or equal to, and we're going left or right. So the biggest takeaway, okay, our graphs either go apart or come together. That's the only thing we're doing in Algebra 1. Now in the big picture, are there other options? Yes, but Algebra 1. If they go apart, it'll say the word or every time. If they come together, it'll say the word and, or X will be in the middle. So there's only one kind of or, but two kinds of ands. Those are your options. Now make sure you check out Google Classroom for your task. Let me know if you have any questions. Seek out other resources, right? Take a look and see if maybe there's another teacher's video that works for you. Do some practice problems with friends. Look for practice problems online. You have so many options to really master this standard, all right? So let me know what you need. And until next time, have a good one.